Example 6. The only difference between this problem and the previous problem is the numerator. The previous problem had a single object in the numerator, this one has multiple objects. But again, the numerator doesn't matter in my decision-making process. The problem, the issue with this problem that makes it not simplified, if this will turn on to the highlighter, this is the problem. 4 plus 3i is the problem. I want that to be a real number. I don't care what the top looks like. When I'm making the decision, how do I fix this thing, that's the only thing I have to look at, the bottom. If the bottom says 6, you're done. You have to separate them up. But again, if it's already a real number, you don't have to fix it, it's already fixed, right? But all the problems you're going to have an imaginary number structure on the bottom, either a single guy, which times I fixes it, or you're going to have a binomial guy like this, so you're going to have to multiply by the conjugate. So, the conjugate of 4 plus 3i is 4 minus 3i. Again, every single time to make a conjugate, the first number is what it is, the second number changes signs. That's how you make a conjugate 100% of the time. Never fails. Fraction world, if I multiply the bottom by an object, a new object, this guy here, 4 minus 3i is new, I got to multiply the top by the same object. Okay, when you're multiplying by multiple things, make sure you put parentheses around that object. Now notice the previous one had the number 10 times this thing, right? Now we have a binomial times this thing, so I'm going to be required to put some parentheses around the top also. So, and again, this is as complicated as they're going to get. A binomial on top, binomial on bottom, and the technique is exactly the same. Make a conjugate, multiply top and bottom by conjugate, and then simplify as much as possible. On top, that simplification looks like this. I'm going to put a fraction bar here for the top. If I want to multiply 5 minus 3i times 4 minus 3i, that means I have to multiply 5 times both objects. 5 times 4 is 20. 5 times negative 3i is negative 15i. Then I have to multiply negative 3 times everything over here. Sorry, negative 3i. Negative 3i times 4 is negative 12i. And negative 3i times negative 3i is positive 9i squared. Notice on top, these guys don't cancel. It doesn't matter. I is allowed to be on top. We need I to cancel on the bottom. Again, that's what we're creating here with this structure. Typically on top, you're going to be left with an imaginary number almost every time. Okay, so, again, 5 times both things, negative 3i times both things creates that product. On the bottom, same idea. I'm going to multiply positive 4 times this entire thing. 4 times 4 is positive 16. 4 times negative 3i is negative 12i. Then I'm going to multiply positive 3i times both of these things. Positive 3i times 4 is positive 12i. And positive 3i times negative 3i is negative 9i squared. And these are the ones that cancel, right? So, again, we want those i's to cancel on the bottom, and they do. Because, again, that's what I've created. And it's not a coincidence. This structure always creates that cancellation of the i's. It always creates an I squared, which becomes negative 1. The same thing happens again and again and again the same way. So it becomes very straightforward for most people. So, at this point, I squared continues to equal negative 1 forever. So, positive 9i squared is just negative 9. If you wanted to go that route, you can put the times negative 1 if you want to, but all that happens, I squared is negative 1, it simply makes this real and changes the sign. So, plus 9i squared is minus 9. Minus 9i squared is going to be plus 9. And that's the effect of multiplying by negative 1. It just changes the sign, makes it real. So on top, if I simplify as much as I possibly can, I've got a real number 20 being added or actually subtracted by a real number 9. That makes a real number of 11. I have an imaginary number negative 15i being added to an imaginary number negative 12i. They're both negative, so I'm going to add them together. They're both negative, so it's a negative answer. And on the bottom, I've got a real number 16 and a real number positive 9 being added, which makes 25. So 11 minus 27i on top is the simplest form of the top. 25 on the bottom is the simplest form of the bottom. And the final thing I'm going to do is separate the two fractions into a real part and an imaginary part. Notice again, the real's in front, the imaginary's in back this time, so 11 over 25 on the front, minus 27I over 25 in the back. And every single answer that you write for imaginary purposes, complex purposes, real number in front, no I, imaginary number in back, I. Each one of these problems, that's how you do it. Your task is get rid of the I on the bottom legally. Simplify everything as much as possible, separate the fraction, reduce it if possible.